Okay, we're on page 175 from lesson 7.1. And there's only one math problem at the bottom of this page, but the first part of this video is just going to go through example 1 and talk about how to take a simple rate, I guess it's a ratio, and find the unit rate and then convert that into both the table and a graph. And then you'll kind of do the same thing at the bottom of the page. All right. So the reading. You can use tables and graphs to represent real-world problems involving equivalent rates. Example 1. The Webster family has taken an express train to Washington, D.C. The train travels at a constant speed and makes the trip in 2 hours. So if you look at the picture, you know that it says 2 hours and it goes 120 miles. So those are the two terms, 120 miles and it takes 2 hours. That's what you know. And just from that little bit piece of information, we can create a complete table and we can create a complete graph. So step 1, or question A says, make a table to show the distance the train travels in various amounts of time. Step 1, write the ratio of distance to time to find the rate. And they set it up as distance over time. And typically you always would do that. The distance would go first. So 120 miles, that's from the picture. Takes 2 hours. And what you need to notice then is that that's not a unit rate. You really want to calculate the unit rate, which is simplify to where our second term is 1. That's the unit rate. We don't want to know how far the train can go in 2 hours. We want to know how far the train can go in 1 hour. 60 miles per hour. It's kind of like what we just did in the ammonia. It was nice to know that it was 100 mils of water for 2 mils of ammonia. It was better to simplify that to get 50 to 1. We use that a lot more. So for step 2 then, it says use the unit rate, which we did, to make a table. Now this information was given to us right here in the reading. It took 2 hours to go 120 miles. So what I'm going to do here is actually I'm going to pretend that I don't have some of this information. So I'm going to white it out. Let's pretend I didn't have this one, and this one, and this one, and maybe even this one right here. Well, how would I get that information? Well, what I don't have on my table here, what is not a bad idea to add at the very beginning, is put your unit rate right here. You know that for every 1 hour you can go 60 miles. That information is so helpful when you find this other missing information. For example, if you try to figure out this missing information right here for 3 hours from 2 hours, and you try to say, well, 2 goes into 3 1.5 times, that's a little unclear, like what you're doing. But if you know this right here, that you're not figuring out 1 hour, you're figuring out 3 hours, you say to yourself, oh, that's just triple. So then you would just take 60 and you would triple it, so you'd get 180. Or the other way to figure it out is to know that the distance is always 60 miles per 1 hour. So really all of these terms in the second row here are just going to be 60 times what they are in the first row. So this missing information right here would simply be 60 times 3.5. You could probably do that mentally. 60 times 3 would be 180, and then half of 60 would be 30. So if you just added up 180 and 30, you'd get 210. Now what about this one right here? Well, if you know that you can go 60 miles for every hour, 60 goes into 244 times, which simply means that this term is 4. So I just showed you these to figure out how to show you how you could, oh, what am I doing there? That's not 60. 60 times 5 is 300. I'm just showing you how you could take that unit rate, and that unit rate is how you can figure out all those missing terms. So then let's talk about how to graph it. So what you do here is you take the ordered pairs. Remember, we talked about that a couple pages ago. The ordered pairs are when you take the whole column, this whole column right here, and you turn it into a 2, 120. That means over 2 up 120. This one right here would be over 3 up 180. Over 3.5 up 210. You'll notice that all of these numbers in the table get turned into pairs, which make that point. We're going to practice that at the bottom of the page. Would you actually try now the your turn on question number 3, and then resume the video when you're ready to check your answer. Okay, so a shower uses 12 gallons of water in 3 minutes. Here's your two terms, 12 gallons of water in 3 minutes. Complete the table and graph. Now right now, you don't have enough information to do that, except that this information right here can go in, and that would go in right here because this 3 is 3 minutes, and that says 3 minutes, so the water would be 12. Now, there's various ways to get all this missing piece of information, but what I would do is I would add a column at the left, which I would find the unit rate. I would say to myself, I don't care about how many gallons it is in 3 minutes. I'd try to figure out 1 minute. And I think you could probably figure that out just by doing 12 divided by 3. You'd get what? You'd get 4. So what that means is for every 1 minute, it requires 2 gallons of water. So for 2 minutes, it would be 8 gallons of water. For 3 minutes, it's 12 gallons of water. For 3.5, well, you're simply going to get that by going 3.5 times 4. And that's going to be 14. Now, what about if we know that it's going to be 20 gallons? We're just going to divide by 4. So I'm going to get 5. And the last one, 6.5, again, I'm going to do that one, figure that one out by doing 6.5 times 4, because it's 4 gallons per minute. So 20, 24, 26. The next question then says to complete the table, and now we got to complete the graph. So the graph means to take the minutes, that's the top row, and count over 1 and up 4. Well, that one's actually not in the graph, so you wouldn't do that one. The first one would be over 2 and up 8. The second one would be over 3 and up 12. The next one would be over 3.5. I'm going to skip that one for now. I'm going to go over 5 and up 20. Over 6.5 and up 26. And that one I skipped, it's just going to be on the line. It's going to be over 3. There's 3.5 right there. Over 3.5 and up, I think it was 14. And if you do that carefully, you should notice a fairly straight line. I'm just going to sketch it to the best of my ability. Perfect.